As clear as it'll go. All right, cool. Let me set up the screen share, and we're good. Cool. Okay, so raise a hand. Who here has used Action Cable? Rails 5's touted new feature. Cool. Just a quick poll. What types of things have you built with it? Chat engine, nice. Tutorial, the chat engine, and the grocery list, and the to-do list, right? Grocery list, aka to-do list with a better label.
Yeah. I didn't even need to do it.
Right on. Has anyone ever done anything else with WebSockets at all before? Cool. Cool. So Action Cable is pretty interesting. Like I said, today's format is going to be more campfire. I'm going to give some tidbits about it, share a little bit of our experience with it, and how we gambled on Action Cable and think we won, so far anyway. I'll first just give a little bit of a primer. Who here has no idea what Action Cable is, what it's good for, and why I should ever care about a WebSocket? Pretty shy. All right. So just a quick primer. Action Cable is Rails' built-in solution for WebSockets. It's an alternative to using Fay or other Ruby WebSocket things. Traditionally, well, WebSockets are a newer technology. They've emerged in the last few years. The difference between a WebSocket and a normal connection to a website is basically, you know, with a normal web connection, you make a single request to it, it gives you something back, and that's it. Oftentimes, you might pull it for new information, constantly refreshing. And so applications that are dependent on serving real-time data traditionally have done a polling model where your browser would refresh the page at set intervals to be able to get more information. You've seen that in things like chat engines, and traditionally that had all been, you know, let's pull for new data every half second or every 100 milliseconds or whatever. The challenge with that approach is it's a lot of requests that, you know, 90% of the time are returning no data, no changes, no changes, no changes, no changes. Oh, somebody updated something, no changes, no changes, no changes. That's kind of what happens. Systems like that tend to be a bit taxing on servers, and it requires a lot of servers to power that type of a thing for a large user base. For a small user base, it's not really a big deal. You can handle that, but enter WebSockets. What WebSockets do is basically think of it as a direct connection that stays open between your browser and the server. That's it in a nutshell. It's no different than any other TCP connection, really, other than your browser doesn't hang up. So both sides, you know, make a connection, say, hey, I want to talk to you. Cool, you can talk to me, and I'm going to stream data to you. That's a WebSocket in a nutshell. I'm oversimplifying, but that's okay. And so the benefit of a WebSocket versus continuously pulling for data is I can push events to you as they happen rather than you constantly pulling for events. So if you're talking about a website that, let's say, services 100,000 people, you go from having 100,000 polling requests per second or whatever your interval was, assuming all those people were on at the exact same time, to, well, a connection is open, but I'm only going to shove you data when something happens. So in the case of a chat engine, you know, maybe I just have a WebSocket open to Jason, not to the whole, you know, wide community. And he types a message rather than me pulling, hey, did you say something yet? Did you say something yet? Did you say something yet? Our server would just say, hey, Ben, Jason said something. Here's what he said, and display that. And so the modern implementations of WebSockets in the browser are really, browser will send typically JSON data over that WebSocket, and JavaScript will render it in your browser, is by and large how the majority of them all work. Cool. So that's a quick primer on it. Traditionally, Ruby hasn't been a strong candidate for a choice in doing WebSockets because MRI is not necessarily a multi-threaded thing. And so it doesn't take advantage of the full CPUs going behind it. There are better candidates out the gate, better languages that do handle threading and multiple concurrent processes and things like that better. Phoenix is really popular right now. Phoenix framework with Elixir is really popular right now. Paul had done some really cool stuff with good old Crystal, the Ruby alternative to C. I don't know how to say that one. And other languages as well. There's pure JavaScript implementations that run off Node.js also. I think that's where Pusher really got its roots, if I recall correctly, and all that. And so, had the fortunate experience this year of being able to work on a new project and use 2016 at the time technology as we started, and we decided to take a gamble on Action Cable and try it for something more than just a chat engine. Well, the very first thing we did build was indeed a chat engine because we actually did need chat as part of our app. So we also built a chat engine in Action Cable. I'll applaud myself and those who helped me. Okay. But we saw a lot more potential in it. The chat engine is like the most basic example you could ever think of why you should use a WebSocket. But it's not all that innovative or cool. We've been chatting since IRC days, and chat's not really a new concept, you know. So, you know, we actually thought, well, if it can deliver things like that, it can deliver anything, right? Because it is just indeed a notification system that keeps connections open. And so one of the biggest fears we had getting into it was, well, it's brand new technology and there is literally zero documentation or research that is real out there on it. One of the most helpful things we saw was an article like this from Dockyard, like Phoenix channels versus Rails Action Cable. Dockyard did this, and it was pretty interesting. They set up a test. It was basically just a WebSocket test, implementing it in Phoenix and implementing it in Action Cable. So they defined, you know, this is how you build a chat room channel in Phoenix. You join, it creates a socket. I'm not going to walk through the code. This is how you do it. This is the equivalent in Action Cable. So they basically had these things like, all right, there's a few number of rooms. And then one of the first things they noticed is like, well, memory leaks. Like, okay, that's kind of a challenge. Some socket close stuff. That has since got fixed, so it's not really an issue anymore. But they went through these tests and were doing some perf benchmark stuff on it, and they had some pretty interesting stuff. Their whole takeaway was kind of like, okay, it works pretty good for small applications. By the time you're doing multiple connection rooms with multiple concurrent users, the more users you add into the more rooms, the more that slows down. And so they went from going 0.05 seconds for their things. It was speedy at 50 rooms, so we upped it to 75. Then suddenly we went to 8 seconds for chat message or something like that. It's like, well, okay. And so, with Phoenix, they did the same thing, similar things, and it remained more consistent. And their takeaway at the end of it was kind of like, well, if they can figure out the memory leaks, which they have, sweet spot for Action Cable is small workloads with a few subscribers on any given topic. But they said something interesting, like higher workloads with broadcast to more than a few dozen subscribers risks availability. Okay. So like more than 50 people is a problem? Like that seems stupid, And the challenge is this is the best article we could find on it. There's a couple others like that where they went through and kind of compared them. But the challenge with these examples is they're tests set up to prove a single point and purpose. And it's not all that indicative of a real life experience. So we did some early implementations of what we've done is we recently just launched a sports app. It's all about real life sports that you play with real life events. So at any given point in time, like right now, there's NBA games going on. We've got Knicks versus Nets that's in the fourth quarter, Pistons, Pelicans, Celtics, Raptors, whatever. We wanted to build a dynamic game based around dynamic sports content. So take like fantasy casual sports and combine it with a cool second screen experience and allow, you know, fans to compete against each other in real time with the event. So we're not trying to override the event. It's not like most games out there where it's, you know, a simulation like Madden or gambling like DraftKings. It's, you know, more of it augments the sport event itself, trying to make it a little bit more entertaining, especially for those who are more casual fans but aren't as diehard. That's kind of the premise of our mobile app. And it's been, we decided that, we had this task of working with sports data providers to sync and store and deliver information in near real time, or as close to near time as possible, for this whole thing to work. Because the challenge is, if I'm like 2 minutes behind the game, I'm irrelevant all of a sudden in football. That's like a drive or two often, and it's a little bit too late. Most sports data sites are really kind of like, okay, this is what happened, and they pull maybe a minute and a half, 2 minute intervals, and it's just data only coming in. But what we set it out to do was build a dynamic game based off of dynamic content where we're generating the rules and the questions based on the incoming data. And we needed a way to deliver all of that information to the users in real time. So we're currently using Action Cable in this app in different places. Chat room, which is the most basic. We're using it to actually deliver our feed and information. We're using it, which is kind of like the game tracker feed, you know, that's going on saying what's happened. We're using it to deliver questions as well to the user, like get your picks in. We're also using it for some notification stuff, and I think that's about it right now. And so we got thinking, all right, if we can use sockets to deliver real-time information to the users rather than having, you know, 5,000 people pull us all at the exact same time for the exact same event, that could sure make our life easier as far as servers go. And it would also deliver things to our users faster than pulling for that information. Because the challenge with client apps is, I don't know if you have good internet or bad. I don't know all these things. These are still problems. But, you know, somebody doesn't get it because their phone didn't refresh. But a socket stays open. And, of course, there's still connection stuff that has to happen. And so we actually push events to people as it goes. And so that's kind of the application we tried to do is, can we actually build like the main component of our game in Action Cable? So like I said, we took a little bit of a risk on it. Before I get into some of the benchmark and metric stuff, I want to talk a little bit about actually how Action Cable was very easy to work within our code base. The delivery mechanisms for Action Cable itself are dead simple. For those who haven't used it before, it's basically the equivalent of creating an AJAX action in a controller, and the rest just kind of happens, you know. Action Cable has some interesting pieces on it. Let's see here. You have this notion of channels that you create for different things. We have a scoreboard. We have more channels than I thought. But the whole idea is like this is our feed channel, and this is how complicated that web socket is, like real production data handling that stuff. You basically say like, you know, stop previous stream, and this is what the name of it's going to be. That's kind of it. It's pretty easy. You can even do things like authentication, like having current user be part of that, so you can customize your channel to specific people. That was one of the things we had to do to make sure, you know, in chat we're getting the right things coming to the right people. main core bit of logic itself is really pretty simple. Like once you have this channel created, you can broadcast to it from anywhere. So that could be from another controller, that could be from a model, that could be from a background process that runs. In our case, we've basically created like a state machine, event machine that's responsible for streaming all this data as it comes in and processing it and deciding what to do. And it runs on an entirely different server than the action cable things themselves, and yet it still pushes it all through there. So, the actual wiring behind action cable is pretty straightforward. You basically have 3 interfaces for it. The main channel that you set up, and you can see how complicated that type of code is. And then you have, some JavaScript that handles the events when it happens and displays that in the view or whatever you want to do. And then you have somewhere within your code that you're populating these channels for the JavaScript to respond to. And that's it. It's like 3 pieces. So it's really pretty easy to work with if you have just a decent understanding of general Rails stack and how to do JavaScript from Ruby code. You won't have a problem at all with it. The only little caveats are just little things like just getting it to work right on the right servers, making sure you have domain names mapped properly, you have cable URLs set up, but even the setup itself and it just happens in your application RB file or any of your environment ones where you just kind of define what protocol you're using and what your host is and set that stuff up. So you can also do like CSRF protection across it by allowing specific origins so that you can access things across origin and that stuff. It really just feels like Ajax-y stuff. But it's really not all that hard to use.
How easy is it to set up secure WebSocket connections?
Very easy. The question is, how easy is it to set up secure WebSocket connections with Action Cable? The only thing you really need to do with that is have an SSL cert on and then just change the protocol from, I don't have it right there, I have it defined somewhere else, but define from WS to WSS and it just does it. So it depends on how your server setup is. Typically I do SSL at the load balancer level, not at the Nginx level per se, or the web server level itself, but depends on your configuration, but it's basically plug and play. The only caveat is CSRF stuff, like you'd see with normal Ajax across other domains or whatever. But yeah, great question. And so that's a nice thing about it is, you can set it up to go over SSL, all your stuff's encrypted, nobody can try and sniff it out or whatever, and do secure communication through that, which I absolutely do recommend you do if you're going to do it. But yeah, from a code standpoint, it's really not that crazy. In our code, we have a few places with code like this that's basically broadcast to whatever the name of the channel is, and then we can just pass arguments into it, whatever we're going to broadcast. And so oftentimes, we've even been successful at not just sending JSON over the view and then building it in the JavaScript layer, but actually sending full Rails partials, Ruby partials views through it, because it's lightweight. I mean, escaped HTML is still very, very light. And it's been pretty good for us where we've done a bit of a hybrid approach between native and mobile stuff within our mobile app. And so we kind of found, as far as best practice goes, is don't try and do it all in the JavaScript layer. Do it in Ruby, then shove that down the JavaScript channel, and your life is better. Unless you're a stronger JavaScript programmer than you are a Ruby one. But I don't like to rework things, and I like to keep my logic in one spot, more on the back end than in the front end of it. And so and the hard thing is, in most of the examples you'll see things like this, like let's stick HTML in the JavaScript, which I don't really like from a pure vanilla JavaScript point of view. My front-end framework friends will disagree with me there, but that's okay. But I don't see any reason why you couldn't combine that with other approaches as well. But the hard thing about that is it's just like, okay, now I don't have good syntax highlighting or error correction, and I can't test that, and I can't do these things that I normally like to do in my code. You know, we've also had good success with presenter models and cache layers for slimming that stuff down and not making it so burdensome on the applications themselves. But really, the nice thing about Action Cable is it actually handles a lot of the WebSocket nonsense for you. It'll automatically do reconnects, so if you lose a stream, it'll just reconnect to it automatically without you having to do anything. What happens is within the Action Cable JavaScript, it is conscious of its connection state, and if it loses it, a callback event is triggered to tell it to try and reconnect. And so you don't have to write special code for like, you know, you've reconnected, click here to retry reconnecting. It'll just do it automatically, which is nice. And it's really pretty straightforward. Any questions around that side of it?
With the reconnecting, can you tap into that so you can say like lost connection?
I haven't needed to. I know you can. You can do some tap into the callbacks around them and do specific things. Like maybe you'd want to display an alert like Slack does when it's can't get a socket connection, reconnecting in 30, 29, 28, right? It does that. They're manually handling their socket connections though, and you can push retry now and do that. I would think you can just fine. I think they have the JavaScript callbacks there to do it, but it would be more on the view layer, the front end layer than on the back end layer. Yeah. Excuse me. As much as your over-the-wire key value store will let you. So it uses Redis as a backend. So
that's that explains where that's just straight up partials.
Exactly. So with that, you don't have any. What it does is it'll push the information to send to Action Cable through Redis so that everybody subscribing to that particular thing can get that and do what it needs to do. You know. So we have not really ran into size constraints with it at all. Obviously, as everybody will say in everything, keep things as slim as possible because, you know, ultimately network is your greatest enemy when it comes to speed, much more than compilation time or anything else, you know. But yeah, there's starting to get some better examples on it just recently. The Rails example is great. It's a great primer, but you'll walk away from that and go like, okay, how do I put this in my real code? And there's kind of no help for you out there, sorry. You just kind of have to figure it out a little bit and dig deep into there. If I was a better man, I'd write a cool video about it or something. There are a few better ones popping up. If you want to look for some specific things, look for things like Action Cable with authentication. And even if you don't care about the authentication, those ones have a much better pattern for how to structure your code on that stuff. We kind of learned the hard way, like starting out doing everything just like the guide said, and that was all of our logic was basically in the JavaScript layers. And then that got really hard to maintain and really hard to manipulate and do what we wanted. And, you know, console dev tools console debugging is about the worst type of development ever. So being able to build and create that code, you know, in a Ruby console was much nicer for us, and we did a lot of that. In several instances, we will do things like I'll show you how we use it once in a controller, just because it's so simple. Here's a simple example of, you know, when we create a chat message, then we broadcast it directly to Action Cable right there, and that's it. There is no create.js.erb or there is no create.html.haml. It's just this right here. That's how you could do it in a controller. I just have this broken out for legibility here. This is an example of us passing in an identifier and also rendering a partial over the wire. So we're actually rendering a view there rather than building that view out in the JavaScript layer. I've really liked that because you can pass in, you know, normal Ruby locals and things like that the way you're used to. you can definitely make the argument that passing JSON is lighter, but you have to rebuild it all into the JavaScript layer. So it's a double-edged sword there, depending on how complex your views are. If it's a single thing, I'd say do the JSON absolutely. But if you're getting into complex styling and you're reusing code from other places, it's just nice to be able to reuse code from other places, not build it manually the normal HTML way and have it in your ERB or Haml in another place. So I'm sure it could. I'm sure you could get React to respond to those just as well. JavaScript's loaded already. I don't see why not. Yeah. As long as you don't do that weird thing where it shows up as like a money symbol then flashes in, I support it. Or curly braces then flashes in. You guys know what I'm talking about. Anyway, we do that in other places as well. Like, I'm just going to show a little bit of this. Like within a model, we do a similar thing, like broadcast this stuff to a server, identify it by the ID of our game, and send that down there. We even throw in a presenter model there so that we have a slimmed down version of our data objects going into it, and it's worked quite well. A lot of that stuff taps into cached items as well, so it's not taking a long time to dig up. Now, one other pro tip I'd give you on this is if you're going to be doing Action Cable and you're going to be doing caching and you're going to be using Redis for anything else, don't use the same Redis. Have two separate Redis instances for everything you do. It might be more expensive, but it's increases availability and decreases likelihood of bottlenecks and problems. When we launched our app, we had some interesting scaling problems. And one of the ones that surprised us was our cache layer was slowing down other parts of our apps because our cache was not well optimized yet. And that did affect other things like messages and notifications and background processes and other things that were using a shared Redis. And so we learned our lesson, don't do that. It's really easy to connect to multiple Redises from a Rails app. They're all configured differently anyway. So yeah. So I wanted to share a little bit of examples of how this has worked for us in the wild. I'm not going to go back in time too far. I'm just going to see some stuff right now. Here's our new relic view. This is apparently a really small screen. Last 30 minutes are ending now. So there's currently some live games, NBA games going on right now. We have like Memphis versus Denver. Let me pull one of these up here real quick. So this is kind of our thing in action. We've been able to do some pretty interesting things with it. Let's grab this one. There we go. Put in the game, package thing, cool. And so yeah, like I said, we kind of took a gamble on Action Cable with the launch of our product. I actually had in the back of my head a reserve strategy to immediately bend and ship on an Action Cable and go for Elixir if I needed to, because I had no confidence in it, because that's what was out there in the market, Of all the scaling problems we had, Action Cable was never one of them. It held up wonderfully. We've, at our busiest times, I think one of our busiest games was, what was busier, division playoffs or just a Sunday night football game in December? Conference championships. So NFL conference championships, Sunday before last was probably one of our busiest games. I think on average we were maybe 90,000 requests a minute. We'd peak out at 110, 105, maybe not quite that high. A little higher. 130 is about the peak that we'd hit. So 130,000 requests a minute. Put that in perspective, right? Like spikes around real-time teams. So in the middle of the day when there's no sports on, we don't have that. But on one of these big events like a football game, like the Super Bowl this Sunday, that's going to absolutely rock our world, but we'll be okay. maybe. We create these artificial spikes of traffic around our app. It's actually really cool to see what we can do with this. But to put that in perspective, okay, in 2013, a bunch of big Rails sites had some surveys and analytics done. End of 2012, before Twitter jumped to Java, they posted their Rails stats saying they would do about 600 requests a second on their app is what Twitter was handling as far as scale goes. At any given point in time, certainly events would drive that higher. Currently, let's see, Shopify does about 750 requests a second. And what's another big one that's out there? I don't. Do you? I didn't know if that was, do you know? Let me tell you. Or do you know? I don't know what they do. It'd be interesting to see. Another one that was out there was, let's see, Shopify. I don't remember, but there's a pretty good article written up about it. I don't know if they are. I would imagine they are.
They probably just straight Rails API now.
Yeah.
They have all the React. So
Probably so. But to put things in perspective, okay, so 600 requests a second is 36,000 requests a minute, right? Which is pretty good. Shopify is like, 750, about 45,000 requests a minute, and they're doing, just tons of transactions at any given point in time. I think, what was one of the other ones on there? I'm blanking right now. It was one of the, another commerce site, not Big Commerce, not I don't remember.
I think they want to move to Java. Sorry, I talked to 16,000.
Ooh, that's what they say right now. That's crazy. September 21st. Nice. There was, okay. I think. Anyway, I don't really know. Anyway, we're looking at some pretty interesting things there. At our peak in one of the games for so what we do is as the game's going, we're displaying this feed of information that you'll see gets updated in real time with events, what happens, the timestamp when it happens. So if you're watching along with it, it comes in and displays the data. Then every so often we'll do picks that you have to answer questions for. You compete against each other. There's kind of a leaderboard of people playing, and you can have, there might be 1,000 or 2,000 or 5,000 or 10,000 individual games for any sporting event. Well, those have a common channel that they're streaming from, but they also have their own individual channels specific to chat for that group or other events for that group. I think at our biggest peak, we recorded like 157,000 requests per minute, was kind of our peak so far. And the cool thing about it is we looked at our server performance times, and they looked exactly like this. It was like slightly higher, maybe closer to 200 on average, and like 23 or 5 on median. And it really didn't even phase it that much. Like our servers were keeping up. And so, putting that in perspective, right, like 150,000 per minute is like 2,500 a second, which is crazy, right? Like a lot of people doing that same thing at once for not being a polling app, that's constantly polling for data, right? And so, that doesn't mean that was 150,000 people doing the exact same thing at the exact same time. It's 150,000 requests that minute. That could be 50,000, or that could be doing 3 requests that minute or whatever. But so it's important to keep those things in perspective. But Action Cable is one of those things that actually survives that just great. It really didn't give us any hiccups there. The only thing that we had to do for it was optimize our web service server layer to handle it a little bit better. Our web servers are much more CPU optimized than a standard web server would be, just because there's so many connections open. But we use it, normal Puma, serving out our Action Cable stuff. There's no special configuration there necessarily other than tuning your Puma workers and threads like you should do in any app.
Is it on its own instance? Like, do you have, is ActionCube a separate service layer?
We actually tried to, wanted to separate it that way in the beginning, and it was more problematic than beneficial. We had some weird problems. We may come back to it. We had some problems with CSRF stuff, like we wanted to do like cable.ourdomain.com, and with the secure WebSockets over it, it was just having some problems, and it ended up working out better just to run it out of our web server layer instead. And so we've just done that.
So are you manually, you know there's a game on, are you manually like saying, all right, let's make our instance count up, you know, to handle it, or do you have like some auto scale?
Yes and no and yes and more. Well, yeah, we certainly have a automated server configuration code that does all of that stuff. We've been toying with some automated scaling scripts. I don't have any in the wild just yet because you have to trust those pretty good. And a lot of our games aren't the place to try them. I have a few more things I want to do there to, reduce counts during off-peak hours. The only challenge with that, with like an AWS or something, is, maybe Docker would be better for this, but with AWS in particular, you're a minute or two or three behind, set up, run all your scripts and up and running. It's not bad. It's enough that you could tolerate and do things with. But we do our configuration management with a tool called Salt Stack. And I do have some stuff I plan on doing soon to do more automated scaling with it. But currently it's just manual scale, then deploy the code, and we have it one command that'll deploy it everywhere, bring new instances up, and it's quite nice that way. So we've kind of built a little.
Our ops guys would say Docker and Kubernetes.
I know they would, and everybody says that everybody says that until they've tried it.
Yeah, we're halfway through trying.
Everybody's halfway through trying it. That's the problem. The challenge with Docker and Kubernetes is they're wonderful for development, and a few people know how to do it well in production, but they're full-time ops guys trying to keep that thing healthy.
Yep. That's cool.
That's not us right now. I think Docker and Kubernetes are very promising. I think they're worth doing in development, especially if you switch projects a lot, or if you're a studio model who comes back to a 9-month-old project or something like that. But I've yet to see a lot of people gracefully using it in production. Let me put it that way. Okay, that's me though. But keep an eye on it. I think it's about a year away from being like, out of the box, let's use this thing, and there's enough documentation and resources and one-click installers to help people get up and running. Doku was supposed to be that, but it's no longer. Now it's part of the other side of it, but yeah. So, that's kind of been our experience with it. It's been really easy to configure, really easy to manage. It's held up surprisingly well. Now that said, we also do scale up our servers quite heavily for big games. I mean, we only probably need 5 servers in the morning when there's no games going on, but we'll scale up to about 50 for a big game. Running 3 procs and 8 threads and 2, 3, 4, 5,000 processes, right? Because that's what it takes to handle 150,000 requests a minute without exhausting your machines. And so we certainly are working on more of that. We've got on the server ops side, it's been handle performance, then cost reduction is kind of our strategy towards it, and we're getting there. So pretty good. Paul, what did I forget? What else should I talk about?
What's your Redis bill?
I dropped a screenshot in your Slack. So I figured out.
Sweet. Yeah, this is a good one. Yeah, so this was
This was from December.
December 1st during one of our games.
So it's basically, that's to optimize it.
Yeah. So I think one of these points, if you zoomed in, was probably where that 150 number was. But what happens, the nature of our game in football is every set of drives we'd ask a new question. And so like people came on before the game, the drive happens, people lose interest. Oh, drive questions available. Oh yeah. Okay, a very fascinating thing. When the game is boring and a blowout, we can keep people engaged and interested in the game they're actually watching.
Is that halftime?
This dip right here is halftime for sure, because we've got 15 minutes there. And then each drive we tend to bump people back up, you know. So that's honestly like what one of our games looks like. It's pretty fun.
Response times.
Yeah. So here's everything here. And this was probably, yeah, even that giant spike right there, the tip of it was 400 milliseconds. You know, as far as those, what's that?
Is that the 95%?
I don't know that. This is just the breakdown. Yeah. This isn't percentile here.
95th on that big spike would probably be 300.
Probably.
250.
Yeah.
That would probably be 2 or 3 requests that long.
Right.
So 30 seconds.
Yeah, and that always happens. You hit a cold cache, you hit something where somebody has to do the hard work and they suffer for it, but you know.
You usually out 1 or 2 battery requests.
But, you know, I mean, to put that in perspective, right, anything sub 100 milliseconds is perceived as instance. Everything, you know, touch time is about 300 milliseconds. If it doesn't go more than that, it feels, you notice, okay? 300 milliseconds is about the threshold where you feel between that was instant and I noticed that it took a minute. Over 1 second is kind of like, all right, I can tolerate this. Over 3 seconds is intolerable as far as UX goes. Because it's I'm waiting. Over 10 seconds is go find a better company, or you're doing something you shouldn't be doing in that view, or something like that, right? And so, you know, we always have a goal. Our team is pretty driven towards performance. We really like to keep the majority of our stuff sub 60 milliseconds where possible. That way, the averages for, you know, some requests just take longer. There's more stuff happening. That way our averages stay sub 100, you know, for the ones that you just can't do that quickly because there's too much going on. And on the API layer, like you'll notice actually, when you look at things like median time, median's a lot more telling than average on a lot of things. You know, a lot of our quick requests are just right down here in that like instant category, which is nice, you know. On the app server layer. The view layer always takes a second longer, of course, and we try and optimize that as well. But anyway, thoughts, questions, comments? I wanted to kind of like tell you a little bit of like action cable in the wild because it's impossible to come by. Honestly, we had the hardest time doing it, you know, and we've kind of cut our teeth on it. Key lessons we've learned is separate Redis, pay for Redis, to your question earlier. It can get really expensive if you don't optimize. Don't use Redis replicas if you don't know how. That is actually what cost me a lot of money. But then I learned how, and it's been phenomenal since. It is not as magical as their docs describe it to be. Let me put it that way. You know, just separate your concerns. I mean, keep it as simple as possible. Treat it like any other controller view presenter model in your code base, and it's pretty easy. So,
are you doing most of your broadcasting via callbacks, or are these more like job workers that are running?
Mm-hmm. So we have a couple. The question is, are we doing most of our broadcasting via job workers or callbacks on specific events, or how? And we do most of our broadcasting through a state machine that runs. We have 2 types of background processes. One Sidekick, normal jobs, but the other Clockwork to do things at specific intervals, like smart cron. We use that. So basically, while a game is active, every second or 2 seconds or 5 seconds or whatever the appropriate interval for that specific game is, fetch and pull the data, and if changes happened, then broadcast. So we have a state machine that just works on clockwork that does that, and it really builds out the dynamic nature of the games, the questions that gets asked based on the stats coming in, and it's one of those like a dynamic game based on dynamic content themes, you know. So we've never had a single bug doing it. No, it's really pretty. We've kept the process very straightforward though, and it's worked out pretty well. Yeah. Question? Raise your hand. Yeah.
It seems like it could be pretty difficult to test. Were you able to test them?
So one of the problems with the majority of action games is that there's actually no test framework. They're working on that now. Basically, the way action games got released with Rails 5 was everything works pretty well, but all the peripheral things aren't there. Like there are no tools out there to really do performance monitoring for it. Like even New Relic had an article about how they did the action table. Really, all they have is how many requests per minute there are.
Right.
It's a very useless stat for action table because you connect once and then you sit there.
And it kind of calls all of the calls to rack.
Yeah, so the real things you want to monitor, like for concurrent strategies, that's what that article that Ben showed was about.
Yeah.
And there's nothing out there to measure that. There's not really a testing framework. It's not even really hooked into active support notifications for those of you who at least one way you could kind of monitor it. So they're working on a lot of those things right now. So I think whenever 5.1 gets there's going to be a lot of improvements, not to how action table actually works, but how developers can work with it.
It's really
And hopefully put some effort because we've used it a lot and we don't know if we've hit like 100,000 concurrent subscriptions at once or 50 or 10. We can kind of guesstimate based on
traffic.
Pieces of information from it, but we don't truly know ourselves. But to your question, testing.
Well, and the reality is, I'd kind of make the point that because of that, I mean, you know, you see the cable code itself, and it's that simple, right? Like, there's nothing that cool about any of that.
So you're more testing how your code responds to this.
Well, to that point, like, none of our logic is in the front end view label, nor the channel or the cable stuff. It's all in modular data that's easy to test. We don't really do much there. That's why we use presenters or JSON data or partials, and render that stuff through.
It's kind of like controller testing, where if you lightweight controllers,
That's right.
not really too much reason to test.
Other than test that things are working, setting, and rendering properly, right? So it's that same logic as ever. Keep logic out of your views. You know, keep your views stupid. Keep your controllers light, and keep your model smart. You know, and it applies there. Any other questions? Yeah. Yeah, AWS, actually one of the game changers for us has been November, December, they launched Redis 3.2, and that had a lot of great improvements. 2.8, they were way behind on 2.8 for a long time, like way too long. Like they missed Redis 3.0, 3.1, and they finally came out with 3.2. That's how far behind they were. Works very, very well with it. Yeah. Just don't use multiple databases on the same Redis. Like I had a good call with Amazon's Elastic Cache team about it, and they said, "Oh no, don't ever do that." Like, you know, so we already had our cable stuff and our cache stuff separated, but we didn't have like background jobs and other things we're using Redis for separated out, and we did that, and it was better. And it also allows you to scale those appropriately because Elastic Cache can get very expensive, especially when you use their ones that can handle, you know, bigger sizes of cache. Yeah, it's crazy. Cool. That's it for Action Cable. Go out, give it a try. Don't be scared to use it in production because we were foolish enough to gamble on it and it worked. But like I said, because of the straightforward nature of it, like it looked and felt just like any other Rails controller thing. It really did. There wasn't that much different about it. It was just a shortcut around Action controller that tied into Rack directly, basically. I wasn't scared of it because of that, and there wasn't a lot that could go wrong. The only tricky parts were just domain things, what not to do, turbo links so you don't double call closing connections when you don't do that, the normal stuff. And yeah, it's been a great solution for us. It's certainly not our bottleneck right now, and I think, you know, for those specific events, I mean, yeah, we're handling the traffic wonderfully, or at least we feel so. Anyway, that's it. Thanks, guys. Let me stop this somehow, somewhere. That's on there. There it goes. Cool. Don't tell me I recorded myself.